Hi, this is Mrs. Often, and I'm here with a review of angles in trigonometry. In trigonometry, remember that angles can have positive and negative values. They can be over 360 degrees, so we're going to review some of those terms and the conversions today. A few vocabulary words. A radian is defined as the ratio of the circumference of a triangle to its radius. So 1 radian is equal to the circumference of the circle divided by the radius. 1 degree is 1/360th of a circle. An angle is said to be in standard position if its vertex is at the center, its initial side is along the positive x-axis, and we're measuring either positively or negatively. And then a reference angle, also noted as theta prime, is an acute angle that measures from the terminal side to either the positive or the negative x-axis. So let's recall how to convert between radians and degrees. If you have radian measure and you need to convert to degrees, you should remember that pi radians is equal to 180 degrees, because each of those represents halfway around a circle. So I can either do theta times 180 degrees divided by pi, or if I'm working in decimal radians, I can do theta times 180 divided by 3.14. If I'm converting from degrees to radians, I use the reciprocal. Multiply by pi over 180, or multiply by 3.14 over 180. If you're saying to me, Mrs. Often, I'm in the machine shop, go ahead. Use 3.14159. I don't care. But please, don't use 3. That's not precise enough. So we're going to convert a few angles to degrees and convert a few angles to radians. Converting to degrees, again, I'm going to multiply by 180 over pi. So converting pi over 12, pi's cancel out. I have 180 over 12, and I can reduce that fraction to 15 degrees. Same thing here. Converting 5 pi over 6, multiply by 180 over pi. Pi's will be reduced out. And I don't even multiply these together. I do try to reduce. I have 5 times 180 over 6, and that's going to equal 150 degrees. And then finally 7 pi over 18, multiplying by 180 over pi. Doing some reducing here, I end up with 70 degrees. I can do the same thing to convert to radians, only now I'm going to use the reciprocal of that fraction, multiplying by pi over 180 degrees. So now I'm going to lose the degrees. I get 75 pi over 180. Do not leave your answer as 75 pi over 180. This is reducible to 5 pi over 12. Negative 120, be sure that if you start out negative, your answer stays negative after you convert. So multiplying this together, again, I'll have negative 120 pi over 180, and I'll reduce that to negative 2 pi over 3. And finally, multiplying 225 times pi over 180, I'll get 5 pi over 4. So that's converting back and forth between radians and degrees. A little reminder on how to determine reference angles. Again, reference angles have a measure between 0 and 90 degrees. they measured the distance from the terminal side of the angle to the nearest horizontal, that is the positive or negative x-axis. We have rules for calculating a reference angle in all four quadrants. In quadrant 1, the reference angle theta prime is equal to the angle theta. In quadrant 2, theta prime is equal to either 180 minus theta, or if you're working in radians, pi minus theta. In quadrant 3, theta prime is equal to theta minus 180, because we've passed 180 and want to see what's that leftover piece. Or, again in radians, theta minus pi. And then finally, in quadrant 4, we've almost made it to 360 degrees, but not quite. It's that little leftover bit that's our theta prime value. 360 minus theta gives us theta prime. Alternatively, in radians, 2 pi minus theta gives us the value for theta prime. So, we're just going to practice with a couple of examples of finding the reference angle. So in my first problem, my angle is in quadrant 1. And remember, in quadrant 1, theta prime is equal to theta. So my theta prime value is just going to still be that 48 degrees. In problem 2, my angle is located in quadrant 3. In quadrant 3, the rule is the angle minus 180 degrees. That means that my value for theta prime is 45 degrees. In my third example, I've switched over to radians. And I did this because I know everybody loves working in radian measure, especially when fractions end up being involved, as they are here. This angle, 3 pi over 4, is in quadrant 2. So what I'm going to do is subtract pi minus 3 pi over 4 to find my reference angle theta prime. Pi is the same as 4 pi over 4. If I subtract 3 pi over 4 from that, I get that my reference angle theta prime is pi over 4. And finally, 11 pi over 6 is a quadrant 4 angle. And so I have 360 degrees, or 2 pi, that I'm going to subtract from. So 2 pi, if I change that fraction, it's going to be 12 pi over 6 minus 11 pi over 6. My answer is going to be theta prime is pi over 6. And that tells me again how far away I am from 2 pi radians. Now the very last example here is 270 degrees. 270 degrees lies on the border between quadrants 2 and 3. So people will say to me, what should I do? Well, the fact is, this angle, 270 degrees, behaves very much like a 90-degree angle. It is called a quadrantal angle. And quadrantal angles, for our purposes, we do not define as having a reference angle, but if you had to say what acute or obtuse or right angle does this behave most like, this behaves most like a right angle, 90 degrees. And in our final slide, I just want to give you some benchmark angles. It's worth it to memorize these. In degrees and radians, often you have to go back and forth, so it's useful to know 0 degrees is 0 radians, 30 degrees is pi over 6, 45 is pi over 4 radians, 60 degrees is pi over 3, and 90 is pi over 2. If you have all of quadrant 1 memorized, you can continue to use that via reflections in the other 3 quadrants. So I'll just tell you that 180 is pi, of course, 270 is 3 pi over 2, and 360 is 2 pi. Quadrant 1, 0 to 90, quadrant 2, 90 to 180, 180 to 270 is quadrant 3, 270 to 360 is quadrant 4. And there are your angles and quadrants in trigonometry.